Hello, it's more math with a black rat. No, not more black rats, Seek. It's only you. It's more maths that we have. Okay, sweetheart, you have to move now. Okay, so today's problem has to do with a trigonometry question. It's to do with the sine rule. And we've been given a triangle, ABC, and some information about it. We know one angle down at A is 25 degrees. We know the angle at B is 40 degrees. We know that length BC is 14 centimeters, and we're interested in side AC. And this would be just a straight up trigonometry problem, but there's an added twist. We are told that these values, so presumably the two angles and my side of 14 centimeters, have been measured to the nearest two significant figures. The values are correct to two significant figures. Now, this is a weird thing to say in this kind of a context. In reality, when you measure things, you do measure to the nearest millimeter or to the nearest degree or however good your tools are. So in that sense, that's a real kind of a question. In the context of GCSE, trigonometry, I think it's a weird question. But we can scratch it out, and here's what you're going to do. So first off, I'm going to ignore the measurements, and I'm just going to set up sine rule. So sine rule says the following. It says that, okay, so we've got our naming convention with the vertices are capital letters. And we also call the angle by that capital letter. So I would call that angle A, even though that's the point A as well. I'll use the name the same because it's clear in the context of a triangle what I mean. So this is angle A, and the side opposite we call little a. So I know that side little a is length 14. And side little b, that's opposite my 140 degrees, that's side little b. And just for completeness, opposite angle, that's a capital C. Opposite is little side c. It doesn't matter too much about being careful to draw a lowercase c. By context, it's probably clear that you know whether you're talking about the side or the angle. So the sine rule says, you can write it two different ways. It's equivalent. I'll show you both. So the sine rule says that the length of side A divided by the sine of his opposite angle will give you the same value as if you take side B divided by the sine of angle B, and that will be the same as the length of side C divided by the sine of the angle at C. Maybe I will make that a little lowercase c. So this is the relationship. You can say it the other way up with your fractions. You could say sine A over length A equals sine angle B over length B equals the sine of angle C over length C. Either way up, it doesn't really matter, and you can take them pairwise. So this is what I mean. We're given angle A and side A, so we've got those guys. We're given angle B, and we want side B, so we're after those guys. So since side B is the one that I don't know, I think I'll just take the relationship where he's on top. And if this is weird and unclear, please let me know, because I can talk this through in more detail. Right now I'm talking about what to do with this question, but if you'd like to see sine rule in more detail, let me know. Okay, so I'm going to take these upper fractions and say A over sine angle A equals B over sine angle B. So my length little a is 14, and angle A is 25, so I got the sine of 25 degrees. I don't know B, so I'll just leave it as a letter, but I know angle B is 140. So I've got the sine of 140. This is now algebra, and I'm going to deal with the algebra. I will multiply both sides by the sine of 140 degrees, and I've solved for B. So that's 14 times the sine of 140 degrees over the sine of 25 degrees, and that's side B. That's my side AC that I was interested in the question. So under normal circumstances, I would just slap this through my calculator, and there you go. But they say that our measurements were to two significant figures. And the question is, what's an upper bound on this side? In other words, can you give me a maximum value for this side? In other words, if I measured the angle a little bit too big or a little bit too small, how is that going to change this calculation? If the 14 had a plus or minus on it, how does that affect the calculation? I'm going to do this systematically, and I'm going to use the idea that if you want a fraction to be big, so let me write this out. If you want a fraction to be big, if want fraction big, this is a math lesson, not a grammar lesson. If you want a fraction to be big, then you need a big numerator and a small denominator. In other words, if you had something like 7 over 3, well, if I bump that 7 up to 10 over 3, that's going to be even bigger. Or I could have said, make the 3 smaller, make it a 2. So I can bump up the numerator, or I can shrink the denominator, or I can do both. 10 over 2 is going to be lots bigger than 7 over 3. And I guess these are kind of icky decimals, but you can, you can see it on your calculator that this will be the case. So what I want is the maximum value that measurement of 14 could have been. I need the sine of 140 degrees to be as big as it could have been based on this angle, and I want the sine of 25 to be as small as it could have been based on this angle. And here's the bit where I don't really like this question. It's easy to deal with the 14, but the angles, you kind of have to play with it a little bit because it's not obvious, and I think it's just a weird thing to say, but that's okay, we'll shake it out. So here's what I'm going to do. Okay, so on my measurement of 14, that was to two significant figures. Say that fast. To two significant figures. Okay, here are my two significant figures. And that means that I could have been as low as 13.5 or as big as 14.5, and either of those would have rounded to 14. So my 14 is in the numerator, so I want the biggest value, so I'll take 14.5. Okay. And that 140 degrees. Here are my two significant figures. It's the 1 and the 4. So whatever that third digit was, it gave us 140. So you could have been as low as 135 or as degrees, or as high as 145 degrees. And those would have rounded to 140 for two significant figures. So the thing is, I want the sine of those angles, and I want to know which one is bigger because I need that in my numerator. So I'm not going to spend any brain power on it. I'm just going to slap it out in my calculator. So the sine of 135 degrees as a decimal is about 0.707-ish. Okay, so the sine of 135 is about 0.707, and the sine of 145 is going to be about 0.573, so that's a lot smaller, 0.573, blah, blah, blah. Okay, so I can, there it is on the calculator. So I can see that the sine of 145 is much smaller than the sine of 135, and that value was in my numerator, so I'll presume that the angle was 135 degrees, and we'll go with that. And I'm going to do the same game with 25 degrees. So 25 degrees, the 2, the 5, those are my significant figures that could have come from 24.5 or 25.5 degrees. And both of those will round to 24. No, they won't. My goodness. 24.5 will round up to 25. 25.5 will round down to 25. Those are the boundaries on that figure. You can see why I don't really like these questions, but that's okay. We're brave. We can do it. So I need to look at the sine of that value. So the sine of 24.5 degrees is approximately sine 24.5, 0.414. I'm not interested in being precise. I just want the comparative measurements between that sine and that sine. So oops, oh, nice. Answer, please. That was about 0.414. 0.414, blah, blah, blah. And if I do the sine of 25.5, 0.4305, blah, blah, blah. That's enough. That's enough that I can see the difference there. That's approximately 0.4305, blah, blah, blah. Okay, so do I want the small one or the big one? Well, the sine of 25, that's in my denominator, and if I'm trying to maximize the fraction, I need that to be small. So the smaller of these two ratios happens when I use 24.5 degrees. So here was my algebraic solution for the side I'm interested in. But because we have rounding errors on our measurements and I want to know an upper bound for b, I'm going to do that same fraction, but I'm going to use those numbers instead. So I'm sorry it's gone off the page a little bit, but I will repeat it. So the max possible value for side B is going to be, I'll use 14.5 times the sine of 135 degrees, and on the bottom I'll divide by the sine of 24.5 degrees. And that's going to come out approximately as, so 14.5 times the sine of, what did I say, the sine of 135 divided by, isn't that slick to do the fraction button? I didn't grow up with calculators like that. I just think that's really slick. Then you divide by the sine of 24.5. Okay, so there's my input. Press equals, and it comes out as 24.72, blah, 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 blah. Now the interesting thing is, how do I round this number to answer the question? The original question was to do with two significant figures. Should I give my answer to two significant figures? Do I want to say 25 is my upper bound? Do I want to be more precise and say 24.7 or 24.72? I have no earthly idea. So I'm going to pick one decimal place because I feel like it. And I'm going to say about 24.7 centimeters is an upper bound. Actually, it's a little bit, okay, see, this is where it's sticky. It's a little bit bigger than 24.7, but am I justified in saying 24.8? Because that doesn't round me up to an 8. So I think this is a difficult question for what to say for this value. So I'm just going to say maybe. I know that my math is solid. I know that my trigonometry is okay. I know that this is proper maths. And I know that this idea for fractions that's solid. I know that if I have a big numerator and a small denominator, that's how I can make my fraction big. And this plus or minus rounding business, that's solid too. I know that if you tell me that 14 is good to two significant figures, that could have come from values as low as 13.5 that you measured, or values as high as 14.5 that you measured. And if you want two significant figures, that'll give you 14. All of this is fine. And this is fine. I don't know what to do for an answer at the end, so this is the best I can do. Shred. Don't shred my math. No, you can't chew on my math. Get off my math, Zeke. Okay, so there you have it.